OCR Statistics Bivariate Data 1. This is video 1.2, which is on scatter diagrams. The most common visualization for bivariate data is a scatter diagram. Each point on the scatter diagram represents a single statistical unit which pairs the data. This could be a person, or a company, or a country, for example. Each axis is a scale, representing one of the variables, and we need to decide which variable goes on which axis. Let's look at the first, case A, where we have random on non-random data. If one of the variables is independent or controlled, this should be plotted on the horizontal axis. A horticulturalist is investigating the yield of tomato plants when different levels of fertilizer are used. In this case, levels of fertilizer is controlled, so therefore it is the independent variable and must go on the x-axis. Because in this case the yield is a dependent variable, it's as a result of the level of fertilizer, it will go on the y-axis. Notice in this case a particular level of fertilizer has been used on pairs of plants. So you can see a particular level of fertilizer and there are two plants with different yields here, and this pattern repeats as you go along. When the data is random on non-random, the data points will appear in distinct vertical lines based on the controlled treatment levels. Now, in case B, we have random on random, and this is when both variables can be considered to be random variables, and it makes the choice of axes less clear. However, it may be that one or more is naturally seen as a function of the other, and this determines which variable is plotted on which axis. In this example, an ice cream seller is recording the maximum temperature along with the total sales for each day in August 2017. This data is random on random because neither variable is controlled. However, we naturally assume that the temperature is influencing the ice cream sales and not the other way around. So we put maximum temperature on the x-axis and ice cream sales on the y-axis. Generally, for random on random data, there will be no distinct vertical lines. The scatter diagram appears as a data cloud in this general shape here. In this example, a marine biologist is studying the distribution of a species of crab in coastal rock pools. She randomly picks a sample of areas with 1 square metre. She's randomly chosen them. For each area, she then records the distance from the sea along with the number of crabs she can find in that area. This data is random on random because neither variable is controlled. We know that the distance from the sea is what will affect the number of crabs. So we can put the distance on the x-axis and the number of crabs on the y-axis. A random sample of Year 13s are taken and each student's height and weight is recorded. Again, this data is random on random, but we would expect height to have an effect on someone's weight. So we would put the height on the x-axis and we would put their mass on the y-axis. We still have a random sample of Year 13 students, but in this case we're looking at hand span and foot length. Now, this data is random on random, as neither variable is controlled. However, each variable does seem to be a function of a third variable, which is height, because height will affect both foot length and hand span. So it's not really important which axes we put on which, but I would probably default to putting hand span on the x-axis, and that's purely because it's listed first in the question, and foot length on the y-axis. So this was video 1.2 on scatter diagrams, and the next video in this section is 1.3, using and interpreting scatter diagrams.